Okay, in this video, we are going to walk through how to use Cura to prepare your digital model for the 3D printer. Cura is a slicing software, and it is imperative to use the slicing software to make sure that your 3D printer can read the digital file that you created. So this is the file that I created in another video for the stamp project. And this is a 6-sided stamp. So you can see there's a recessed thing on the bottom, and there's something different on every side. So now that I have I've created this file in Tinkercad and I've exported it as an STL from Tinkercad. Then what I did is I then opened it or imported it into Cura, and so now I have this file here. And what I'm going to do is I'll walk through this relatively quickly, but what you want to do is make sure that you have the right printer set up here. So you can have several different printers in, and what this does is it allows you to set the parameters of the printer, the type of extruder it is, the size of the print bed, and all that kind of stuff. I'm using the large printer today. Now, this is a very small object. It's like an inch. So it's not really necessary to use the large printer, but it's just already hooked up and I already have it loaded and everything. So I have PLA is the type of filament. This is important that you have the right filament selected here. So I have PLA. And I'm going to print this on the fine setting. There are several settings in here that are preloaded. And so it's just a texturing tool. It's probably not necessary to print as such a fine, but I think it'd be nice to have a smoother surface. So I'm going to put fine here in this 0.1 millimeters. And so what I'm going to do here is I will kind of walk through. I'm not going to change all of these, but layer height is how high each layer is as it puts down. Also, when you roll over this, you can see a little window pop up that kind of explains what it is. So since I'm going to be using this tool to press into clay, I don't know how stiff that clay is going to be. I think I'm going to leave this at 0.8. And that's a relatively thick, it's thick enough for it to be strong. The infill density, I'm probably going to leave this at 20. However, and that's pretty normal to have 10 to 15 to 20% infill. What infill is the space within the object. So what it'll do is it creates like a sort of network that allows the printer to print flat on the top if it has, it's basically a support system on the inside. So, if this were a large object, and I were to print, say, at 50% infill, now that is really a lot of infill, so you would almost never do that, but you can see down here the estimate went up by 10 or 15 minutes. Okay, so now on a larger object, your estimate might go up by several hours, and it's not uncommon to have a large object that prints for, say, 8, 9, 10 hours even. So anyway, what we're going to do is we'll set that back at 20. We're going to leave the printing temperature at 200. That's the temperature of the filament. And these are Celsius, so 200 is actually quite hot. I'm going to change this to 50, and that's just been working well for this particular printer. I'm going to leave the diameter at 1.75. That's the thickness of the filament that I have already loaded. I'm going to leave the flow at 100, and I'm going to enable retraction. This just makes it so that it pulls the filament back a little bit so it's not so messy when it changes direction and things like that. So I'm going to leave this print speed, travel speed has been working pretty well. I'm going to leave the print cooling enabled. And now this one, what I'm going to do is I am going to generate the support here because what it'll do is it's going to allow me to print, sorry, my computer is a little bit slow today. It'll print some support underneath here. So the support is basically like a little temporary scaffolding that just builds off the bed here and allows the printer to come out here flat. Okay, so if I don't have that, the printer can come out here and then this is going to sag down while it's printing the other layers, and it's not going to be a straight little cylinder here. And so I have a couple options when I generate the support. I'm going to have the option of everywhere or just touching the build plate. Everywhere means every time it sees like a flat overhang, it'll print a little scaffolding even up in here. And that's what I'm going to do for this particular object. This is the kind of thing that really just depends on the object that you have. And, so you're going to have to kind of, ask some questions and kind of experiment with this. But what I'm going to do is I'm going to say everywhere. And then this is the build plate adhesion option. Basically what this does is it allows for the printer to print like almost like a raft or like an extra sort of patty of material here that will help it stick to the build plate. Now this object here is already pretty flat, plus I'm going to have the scaffolding for each side here. So I don't think I need to have a build plate adhesion, so I'm just going to hit none. And again, that's something that's going to change for each object. And so, and then the last thing is I'm going to leave this at all at once. Excuse me. Okay, and so now I have this option here, or this estimate of 53 minutes. That sounds good. This is a small object, so that's fine to wait 53 minutes. And then what I'm going to do is I'm going to save this. And what this is going to do is it will save a G-code file. And the G-code file is what the printer actually reads. And it has all the instructions for where the printer needs to move the printing arm and the printing bed and how much filament to put out. So this is a critical file, and the file that is actually read by the 3D printer. So once I save that, then I'll create the G code, and then I'll put the G code into a little micro SD card and put the SD card in the printer, and then we'll print it. So that's it for this demonstration. And just remember that you have to make sure you have the settings correct for your printer. And then you might not be able to get this on the first try, but once you once you get something that works, make sure and write down all these all your parameters here so that you can replicate it in the future. So that's it for this one, and we'll get this thing printed, and then we'll get to the clay.